Alright, let's continue. Let me open the table of content first. Okay. We are still in chapter 28. I feel like it's getting harder to... What is it called? Getting harder to understand. Maybe that's the word. So yeah, we are taking a look at this homework simulation. Let me open that 28. Okay. Here in this section, the last time is that we are checking the Peterson code here. Wait, what is it called? Interrupt frequency, right? Different interrupt frequency. And now, maybe let's take a look again at this to revisit something like that. D6 log. Okay, this info. Okay. Yeah, let's take a look at this. What is it called? Simulation with Peterson code, I guess. Something like this. Okay, if I remember correctly, there's something interesting here. Maybe this one. Basically, what is it called? Basically, we turn on the flag on both thread, but somehow we still have mutual exclusion. Maybe something like that. Yeah, let me take a look at this aside, This is the Peterson algorithm, right? Or maybe no mutual exclusion. Yeah, maybe this one. The figure that I want to show is basically the problem here, right? Is that both threads set the flag to 1. And I assume that's what happened in here. Right? We set both flag to 1, and somehow we are preventing what is it called? Another thread from accessing critical section when the current thread still running. Maybe something like that. Which is quite interesting. Oh, wait a minute. Yeah, maybe this one. I kind of forgot. Where is the critical section? Oh, no, not that one. Yeah, this one. Okay. Oh, okay. Maybe this one is the critical section. So we are entering the critical section on thread 0, right? Or maybe, should I decrease this to 5 instruction interrupt will begin every 5 instruction rather than 6. Let's find out. Okay, alright, we set the flag to 1 in this what is it called, process maybe. Okay, turn AX. Oh, okay. Okay, we are in this section, right? And then interrupt. Okay, kind of the same, I guess. Okay, oh, okay. So I assume, wait a minute, spin 1. Okay, we are going back to this on thread 0. Okay, and then this one too. Okay, we are going back to this section. Alright, I think this one is moving to the, what is it called, critical section, maybe something like that. And then on thread 1, what is it called? We are going back to this section, spin 1 section, something like that. Continue critical section. Okay, release the lock, halt. Okay, and then continuing the rest of that one. Yeah, this, what is it called? This pin 2 is interesting, you could say. Like, how do we decide that? I think this one, right? So we check if AX equal to CX. Yeah, I'm not really sure. What kind of intention checking this? I mean, from my note, right? What is turn supposed to hold? This is my hypothesis. Turn can hold either the current thread or another thread turn. Current thread or another thread turn. So maybe, oh, and CX is holding the next thread turn consistently, maybe. We are on thread 1 here, right? The next turn or another thread turn is thread 0. So this is 0. And if we are on thread 0, another thread turn is 1. Maybe this is consistent. And I'm still not sure yet. But if this is consistent, right? So basically we check if another turn the same as the turn here. Maybe. Okay. Yeah, this kind of test is interesting, I guess. And I'm still not really sure. Okay, about the intention. But at least for this scenario it works, maybe. See this one, right? After we release the thread, now we change the turn back to the, what is it called? To the another thread turn. I mean, there's a command too, right? Make sure it is other's turn. So there's a case that this turn variable or global variable will have the current thread turn. That's why my hypothesis is something like this. Current thread or another thread turn. Maybe not necessarily next. Another thread turn. Something like that. Okay, yeah, that's quite interesting. But I'm still not quite sure. Especially about the test here. Right. Like, what is the intention here? Yeah, I'm still not sure. Maybe one day I will know. Who knows? Okay, can you control the scheduling with the test-p flag to prove that the code works? What are different cases you should so hold? Think about mutual exclusion and deadlock avoidance. Deadlock avoidance. Okay. Test-p flag. So instead of using consistent, what is it called? Consistent interrupt frequency, we give inconsistent interrupt frequency. Okay, so where do I give interrupt then? Okay, we set the flag in here, right? If, okay, let me try. 1, 2, 3, 4, 5. 5. So 0, 0, 0, okay. I think 5, and then the thread 1 will have 6. Maybe something like that. 1, 2, 3, 4, 5, 6. Okay, let me check. Okay. So we set the flag in here, right? And then we change the turn in here on thread 1, so the turn becomes 0, right? But then again we have put flag turn on here, and then change the turn to 1 on thread 0. Maybe putting the heater 6. Okay, maybe. Okay. And then move. Okay. Make the turn to 1 when we are on thread 0. And then okay, turn AX. We are going into spin 2 on thread 0. Okay, this one. This. Okay, spin 1. We are in this section or instruction. Okay, test. Spin, okay. Okay, we are spinning on thread 0, okay. We are going back to this one. Oh, and then thread 1 entering the, what is it called? The critical section. Okay, so maybe this test the site, what is it called? When both thread, how to explain this? When both thread set the flag with the side which thread hold the flag by turn. Okay. Where is it? Info. What is pintu instruction about? Maybe it is the instruction when both threads set the flag with the side which thread holding the lock by taking a look at the turn variable value question mark. Because again, I'm not sure if this hypothesis is correct or not. Maybe that is what this pin to testing. So we check if turn is our turn or not, the current thread turn or not. And in this case, right, can be because we are doing this after both threads set the flag in here. We are doing this, so the one that gonna enter the, what is it called? The one that gonna enter the critical section is the thread 1 according to the turn global variable value, if I understand correctly. And that's why this, the thread 0 is still going and spinning, I guess, right? But the thread 1 already moved into critical section. This one. Okay. And then release the lock. Change the turn to another thread turn, not the current thread turn. Here is the difference, right? Okay, and then hold, and then now thread 0 entering the critical section. Okay, maybe something like that. To prove that the code works, I'm not sure what should we prove. If it is mutual exclusion, I guess we already done that. But yeah, maybe we need another proof. I'm still not sure. What kind of proof do we need? What are the different cases you should show hold? Wait, if I remember correctly, right? There is not only about mutual exclusion. I think there's criteria. Basic criteria here. Maybe this is the proof. Okay, the first criteria is mutual exclusion here, and then fairness. Okay, does each thread contending for the lock get a fair shot at acquiring it once it is free? Another way to look at this is by examining the more extreme case. Does any thread contending for the lock starve while doing so, thus never obtaining it? The final criterion is performance. Okay. Specifically, the time overhead added by using the lock. There are a few different cases that are worth considering here. Okay, no contention. One single thread is running and grabs and release the lock. Overhead doing so. Multiple threads are contending for the lock on a single CPU. Okay. For fairness, I think at least in the two-thread case here, maybe it is quite fair, because again, it's only two thread. So if one thread already finished the other thread will immediately get the, what is it called, the CPU resource, something like that, for computation. Maybe, but for performance though, I'm not sure how to check that yet, at least. Yeah, what should we check with this uppercase P flag when we can control the scheduling? Okay. I mean, during context switch, we save the content in the register, right? So it's not gonna be changed across thread. And one. If let's say maybe we can also have interrupt in here, but then that might be the same as previous case with consistent interrupt every 5 instruction, maybe something like that. See this one. After setting up the flag, we immediately context switch, right? Now we turn, okay. We change the turn global variable here. Okay. And then we are spinning again on thread 0. Oh, wait a minute. Spinning again. Oh, because the value in AX is the previous, what is it called? The previous turn rather than the current turn. So maybe the, what is it called? The value is kind of out of date for this test, so that's why we keep spinning, right? And then this one is also keep spinning because, yeah, we in both of this thread 0 and thread 1, we have out of date turn value. So at least both of this thread will keep spinning once more than necessary. Now thread 0 move into the critical section. Now that one still keeps spinning. Okay. Yeah, maybe the interesting part is not every 6 instruction, but every 5 instruction. something like that, because we are testing an out of date. What is it called? Not that one. Maybe this one. Yeah, an out of date turn, maybe. Yeah, this one and this one. Okay. Deadlock avoidance. If I understand correctly, deadlock is when the thread waiting for the lock, but another thread. But the thread that holds the lock cannot release. But the thread that holding the lock cannot release the lock. Maybe something like that. Maybe. I mean, can we check that? Count, return. Compare turn. Yeah. We need to release the lock. Maybe if we have interrupt in here. Having interrupt in here, and then suddenly having interrupt before the release. Is that gonna make any difference? So let's say one thread or thread 0 keep going until this critical section, and then right before this release flag, we have interrupt. And make sure that this speed. I'm still not sure yet. One, two, three, 4, 5, 6, 7, 8, 9. Okay. Maybe every 5. If it is every 5 instruction, the interrupt happen. 3, 4, 5. And then 1, 2, 3, 4, 5. Okay, this one is 6, 7, 8, 9, 10, 11, 12, 13. Okay, let me check. 6, 7, 8, 9, 10. 11, 13. Okay, something like this. Maybe. Basically, when we are at the critical section, suddenly we turn back to this, we change the turn, and then maybe both of this thread will what is it called? Will enter the same critical section. Will enter the critical section at the same time. Maybe. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let me try. Oh, wait a minute. Turn the spin. Oh, did my calculation miss? Okay. Yeah, looks like it is missing or not. Oh. Okay. Let's finish. Oh, we are spinning again. Okay. So maybe we are spinning again, huh? Let me think. If we have interrupt in here, yeah, I'm trying to check if we can produce deadlock or not. I'm not sure if we can or cannot do that. I'm just curious, you know. we use turn here, if we interrupt during this turn, the turn will change, right? Yeah, let me turn in here. Let me check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So before this one, right? And then we move back to this one to change the turn, and then move back again, maybe to check this one. The turn should be 1, I assume. So we keep going into this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But then if the turn is 1, yeah, at some point thread 0 will be going back to thread 1. Now let's try this for now, I guess. Okay. We change the turn, going back to this one, and we move to the critical section, and then moving back to thread 0. Okay. Into the second spin here. Okay, we finish. Yeah, I'm not sure. With the current scenario, we can produce deadlock, reproduce deadlock scenario. Yeah, maybe I'm just not sure how to do that yet. I mean, I'm still new, so yeah, let's continue. First, I guess, now study the code for the ticket log in ticket.s. Does it match the code in the chapter? Then run with the following flag. Okay. Causing each thread to loop through the critical section 1000 times, right? Watch what happened to the thread spend much time spinning waiting for the log. Ticket.s. Okay. Oh. Okay, grab a ticket. I think the ticket code means, where is it? Maybe this one. Or oh, maybe the bug here. Log with quest test set, test and set here and wake up. Maybe. If I remember correctly, we are setting up the next inline. Okay, does it match? Let me check. Ticket log. The log and unlock code is found in figure 28.7. Okay, 28.7. Oh, this one, ticket logs. Okay. Yeah, I remember changing the turn here. Okay. Okay, let me check. Ticket turn count. Fetch add. Oh, there's instruction fetch add. It is not in this readme. Okay. Okay. Yeah, at least it is exists in the simulator. Type register, okay. Assert. Yeah, what is fetch add? Temp old value, okay. Old value, okay. Okay. I think this one, right? Fetch and add. We get the, what is it called? We get the old value and then add 1 to the old value and then return the old value. If I understand correctly, maybe that's what this is. Value. Maybe value is the current value. Or the value from AX here, maybe. Let me check. The arguments spread by comma, okay. Arg1, arg2. SRC. Okay, the value is SRC here. But where is the SRC? Oh. Get arg. Okay. destination split. Okay. Okay. Argument. Okay, we also return the type here. So source, I assume, is the value in register AX for this fetch add, and then what is it again? Value register 1, register 2. Okay, we have ticket. This is source, this is value. Okay, I'm not sure what temp2 in here means. Okay, interesting. Destination split. Yeah, I assume the source is this one. The ticket is the value, maybe. But what is this? Yeah, I'm still not sure. Okay, but then probably this one. Yeah, but maybe the point is something like this. We put the ticket plus 1 into register AX. Maybe something like that. Grab a ticket. Yeah, but then we return the previous ticket number. Okay. Check if it is your turn. Okay. Test X. Where do we get the turn? Is the turn gonna be 0? Yeah, I'm not sure yet. Hello, Houston. Figure out Peterson algorithm yet? Maybe, but yeah, I'm not sure if this is correct or not. So previously, let me take a break. Okay. Previously, I'm kind of confused about what this spin 2 is about, right? And I made a hypothesis that maybe it is the instruction when both threads set the flag to 1, similar to, what is it called? Mutual exclusion here, maybe something like that. And that's what I found interesting in the Peterson algorithm. There's a case where, not this one. Maybe something that have the header. Yeah, maybe something like this. There's a case when both thread 0 and thread 1 set the flag to 1. So maybe this pin 2 to check if what is it called? To check which thread that we need to run when both thread setting the flag to 1. Maybe something like that. But yeah, I'm still not sure if that is true or not. Which chapter are you on now? This is the homework simulation on chapter 28. Look here. So we are at the end of the chapter, I guess. But yeah, all of this concept is relatively new for me. So sometimes I revisit the section to check. Currently we are on homework section, checking out this question. Okay. Spin 2 is a second loop. It's just labeling. We're checking the second condition of the while loop. From the C example is abandoned in assembly. Oh, okay, so it isn't a second loop. So maybe with Peterson. So maybe it is one of these conditions. I assume. Yeah, this one, if I understand correctly. If you look at the C on page 7, the while loop in the log function is the equivalent of that assembly. Page 7. Oh, this one, okay. Yeah, this one, right? The second condition for the loop. Alright. Yeah, this is okay. Spin 1 is the first expression, this one, and spin 2 is this second expression. Okay. Yeah, this is what I'm confused previously. Like, what is this condition check, And maybe this condition check if, what is it called? If the current thread should be running or not, especially if both thread setting the flag to 1. Yeah, that is my hypothesis, I guess. Maybe, I'm not sure yet. So this is the first condition and this is the second condition, maybe something like that. For this pin, wait, the second condition is checking if another thread tried to enter the critical section at the same time with it and transfer control over to use in the turn. If another thread tried to enter the critical section the second condition is checking if another thread tried to enter the critical section at the same time we did and transfer control over to us in the turn equal one negative self line. Okay. Try to enter the critical section at the same time we did and transfer control over to use in the turn equal one negative self line. Oh, transferring control over to this turn. Is that it? So if the current thread, or maybe another thread, if another thread trying to enter critical section at the same time we did, we will be transferring control to whatever turn has. Maybe that's it. Okay. So if there is another thread that trying to enter the critical section at the same time as the current thread did, we will check the turn here, right? If the turn value equal the current thread value, I assume we will be the one, or the current thread will be the one entering the critical section. But if the turn value here is not the same as the current thread, or this value, I guess, the current thread value, or ID maybe, then we will pass that to the thread in the turn value. Yeah, at least that's my assumption. Yeah, but again, this is kind of confusing, I guess. At first I thought that turn will never change, right? And then I tried that in the, what is it called? In the simulation. And yeah, the turn value can change. So something to keep in mind. Okay. If self equals one equals self represent the ID of the other thread. Okay, not the current thread. Okay. Yeah, my mistake. Okay. If self equals 0, 1 equals self equal 1. Okay. If self equal 1, 1 equals self 0. Okay. So the expression 1 equals self always gives the other thread's ID. Okay. My explanation is incorrect, so maybe okay. So this one is gonna give, what is it called? The other thread ID, right? So if we check if the turn value is the same as the other thread ID. If it is, let me try. If check if turn is the same as other thread ID. If it is, we pass that. What is it called? We pass control. Is that it? Pass expression. Try to enter the transaction. We pass the maybe the current thread is not going to the critical section. The current thread is not going to the critical section, and wait until the other thread release the lock, maybe something like that. If it is not, the current thread is going to the critical section. Maybe something like this. Okay. Maybe. So we check if, what is it called? Okay, that's basically correct. Alright. So first we check if the other thread flag is equal 1, right? If it is equal 1, we check if turn equal to other thread ID. If turn equal to other thread ID, the current thread not going to the critical section and wait until the thread release the lock. If it is not the same, right? Turn not equal to the other thread ID, we are going into the critical section. Something like that. Indicate that the other, okay, flag 1 negative self equal 1 indicate that the other thread is trying to enter the critical section. Indicate that the other thread is trying to enter the critical section. The other thread is trying to enter the critical section. Okay. Because the other thread also set the flag to 1. Terms of what to do if both threads are trying to enter the critical section at the same time. Okay. Both thread try to yield to the other thread, and whichever yield last, wait for the other thread. Okay. Yeah, that's what is it called? That's what maybe Yeah. Okay, maybe we can adjust this. Okay. What is Pinto instruction about? It is the instruction to check if portrait trying to enter critical section. Okay. By setting the flag to 1, and then we check no, it is the instruction when portrait trying to enter critical section, and then we check if hello ping pong poing, welcome. Long time no see, it's been a while. Yeah, it's been a while. Okay, I'm currently learning about this chapter in case you want to check this out too. Learning about concurrency, trying to understand this Peterson algorithm about concurrency. Yeah, I'm still new to this. Okay, and then we check if let me check. We check if turn at the same time. Okay, and then we check if if the turn is the same as other thread ID, other thread ID if it is, the current thread will not go into critical section. Maybe something like this, and wait for the other thread to finish execute the critical section and release the lock. Something like this. If it is not the same, right? If it is not the same, the current thread go into, or the current thread will go into critical section. And the other thread will need to wait until the current thread finishes. Execute the critical section and release the log. Maybe something like this. Good enough, mate. Thank you. Okay, yeah, maybe something like this, and then okay. At the same time, okay. If this clarifies anything, in English I would word the while loop condition as while the other thread is trying to enter the critical section and it did not yield to us. Spin loop. This clarifies anything. Oh. The while loop condition as the other thread is trying to enter the critical section, like this one. And it did not yield to us. I assume this one, I guess. We keep spinning. Right. Okay. The other thread is trying to enter critical section. Okay. Maybe I should also explain the spin one instruction. It is a condition to check. It is the instruction, or maybe condition, I guess, to check whether other thread trying to access the critical section at the same time as the current thread. Something like that. Okay, it is the instruction. Trying to access the critical section at the same time as the current thread. And spin 2 when both threads trying to enter critical section. Trying to enter, or maybe not both thread. When other thread trying to enter critical section. critical section at the same time as the current thread. After check on spin 1, it is the instruction. Thread, and then we check if the turn is the same. The turn value is the same as other thread IT. If it is the same, current turn will not go into critical section. It sounds to me like you basically get it. Still confused by something. I don't think so. I mean, I'm trying to wording this, I guess. But yeah, from what I understand, what is it called? We will keep spinning if other thread still trying to access the critical section, and the turn here is equal to the other thread IT. So it is not our turn yet. So maybe something like that. And I'm trying to explain this in word. It might be something like this. If it is the same, the current thread will not go to critical section and wait for the other thread to finish execute the critical section and release the lock. If it is not the same, write this one. If it is not the same, then we can access the what is it called? The critical section in the current thread. Okay, correct me if I'm wrong. Alright. Yeah, this is new, I guess. Okay. And then there's also here. Okay, maybe let's continue this on the next session. It looks like we're gonna check a lot of the code here. Test and set, and then also test and set. Yeah. This one, I'm not even sure what that is. Yeah. So I guess we will continue this. The only thing I would add to your explanation is that the reason the algorithm actually works is the yielding to the other thread bit. At the same time, they both yield to each other, which means that whichever one yield plus will wait for the other thread. Oh, it's about yielding. Wait, let me try understanding this. Is that the yielding to the other thread P? If both threads try to enter the critical section at the same time, they both yield to each other, which means that whichever one yields must will wait for the other thread. Yield. Okay, wait. I kinda forgot what yield means. Oh, okay. That they put yield to each other. Okay. Other thread trying to enter critical section. Okay, so maybe not the same time. Okay, maybe. To enter critical section by setting the flag to 1. After check, wait a minute. After check spin 1, right? After check on dot spin 1. And then we check if the turn value is the same. Okay. If both thread trying to enter the critical section at the same time, maybe with safer. No. Oh, put neither is other. Whichever thread yet last will wait for the other thread. The algorithm works because of the yielding to the other thread. Okay, maybe this mechanism works because of the yielding to the other thread. To the other thread. mechanism. If both are trying to enter the critical section at the same time, whichever thread yet last will wait for the other thread. If I understand correctly, maybe something like this. So does that mean if we are not yielding to the other thread, this mechanism won't work? Maybe. Yeah, I mean, if we keep going, well, the turn is not our turn, maybe something like that, then this mechanism or algorithm probably won't work. Maybe. Okay. Yeah, I guess that's it for now. Let's continue this on the next session, looking at this ticket log. Yeah, I'm not sure why we need to enter critical section 1000 times. Well, let's find out on the next session. Okay, so that's it for now. Thank you for watching and see you next time. Bye bye.